Hey guys, and welcome back to another video on the channel. In today's video I'm going to be showing you how to differentiate inverse trig functions. So if you get given an inverse trig function and it takes on the form like the following, then the derivative is the following here. Now what they won't tell you is pretty much the chain rule version of it. So for example, we'll do the basic one here. If you have y equals sine inverse of x on, let's go 2, then all you need to do is put it into this formula here. So dy dx is 1 over the square root of a squared, so in that case it's 2 squared, minus x squared, so that gives 1 over the square root of 4 minus x squared. Okay, pretty simple, pretty easy. But if you get given something like the other way, it doesn't necessarily work all the time and you're going to get something a bit weird. So what we can do is actually use a chain rule by differentiating the inside and differentiating the outside. So if you pretty much have, let's say, let's go u is a function of x, so function of x, and if you have y equals sine inverse of u, that means dy dx will be u dash over the square root of 1 minus u squared. Okay, and yeah, from that you can pretty much work it out, and the other way you can double check is you can integrate it pretty much and you should get the same result. So pretty much let's just do an example. So let's go y, and it also works for the other example, so let's go y equals sine inverse of x on 2. Now we know the result, we know dy dx should be 1 on the square root of 4 minus x squared, okay? But we can show it also using this rule here. So what we can do is, alright, let u equal x on 2, okay? So that means u dash is going to be a half, okay? So when we have dy dx equals u dash on the square root of 1 minus u squared, if we substitute that information in, what we're going to get is a half at the top here over the square root of 1 minus x on 2 all squared. Okay, now this bit here doesn't look like this yet, mainly because we've got some cleaning up to do. Okay, so what we can do is bring that 2 down the bottom of that fraction, so this can be rewritten as 1 over 2 times that square root of 1 minus, and we can apply that squared, so x squared on 4. Now what we're going to do is a little trick in here. We're going to take out a factor of a fourth because we want to get rid of that fraction to make it look a bit nicer. So what we'd have is 1 over the square, 2 over the square root of 1/4. If you factor that out here, what you're going to have is 4 minus x squared. So it's starting to look like that green bit there. Now what we can do now is we can actually break up this third into its parts. So what we can do is rewrite it as 1 over 2 times by the square root of 1 on 4 times the square root of 4 minus x squared. Now this bit here, it goes away straight away because the square root of 1 on 4 is just applying the square root to the top and the bottom of the fraction. So what we can see here is we just get a half because the square root of 1 is 1 and the square root of 4 is 2. So this term is just 1. So what you get is pretty much 1 over the square root of 4 minus x squared. Okay, so this chain rule can work for all the variants. Okay, I will be practicing the tan one. I'm not going to practice the cos one in this video because it's literally the same thing as the sine, except just with a negative. So if you want to work out that cos, just do the same thing with a sine, but just chuck a negative in the front. Okay. What else should we do? We should do another example with the other one. So if we had y equals sine inverse of 4x, okay? This one you wouldn't be able to use using this table straight away, unless you pretty much do some substitution or changing how 4 looks, okay? So what we can do is pretty much use our little rule here, so dy dx is u dash on the square root of 1 minus u squared. So what we can do is, alright, let u equal 4x, so that means u dash is 4, so that means dy dx equals 4 over the square root of 1 minus 4x all squared, so that gives me 4 on the square root of 1 minus 16x squared. Okay, And you could leave it like that. Now there is a way you could actually probably clean it up, but no, honestly, you'd probably just leave it like that, eh? Righto. Yeah, you would leave it like that because the other version would be quite ugly. So that's how you do it for both of those there. Now let's do a tan inverse one. So pretty much with the tan inverse is exactly the same thing. So tan inverse of u, if you want to differentiate that, you're going to have u dash on u squared plus 1. Okay, so it's actually slightly easier. So if we did tan inverse of x on 3 and we used our little formula up here, if we differentiate that, we're going to have 3 over 9 plus x squared. So if we differentiate this with dash, we get, was it 3 over 9 plus x squared? I think that's it. Just double check that table there. Right, but you can get the same result using pretty much our little rule that we have here, the little chain rule, okay? So what we can do is pretty much say x on 3 is u. So we can go, alright, let u equal x on 3. U dash is a third. So now we can substitute it into our formula. So our formula currently is this. So this piece can go there. And then this piece can go there. So what we get is pretty much 1/3 over x on 3 all squared plus 1. So that means we can rewrite that as 1 over 3 times by x squared on 9 plus 1 times by 3 still. So we can distribute that 3. So what we're going to get is 1 over this bit here would be x squared on 3 plus 3. Then what we can do here on that bottom bit is factor out a third. So if we factor out a third out of these two terms here, what you're going to get is pretty much 1 over x squared plus 9, and take out that third. Wait, take out a third. Yes, take out that third, okay? Because if that third gets times by 9, then it turns into 3. Then you can pretty much put that 3 on the top because there's a tip in time, so you get 3 on x squared plus 9, okay? So that was a nice quick little video on how to differentiate inverse trig function. As I said before, I'm not going to differentiate cos because it's exactly the same principle as sine, and tan is almost exactly the same principle, which is built differently, okay? If you have any questions about this video, leave something in the comments and I'll try my best to answer it, but I'll see you in the next one.